Okay, so let's continue with this problem. I am going to try to go a little faster. It shouldn't have taken me 15 minutes for one example in that last video. So remember, you can always pause it if you are falling behind, or if you didn't understand something, or you need me to do restate something. Just rewind, pause, rewind. So the limit as x approaches 2 from the negative side of this function. Okay, that's one thing we need to consider. So what does that equal? So remember, we're kind of following this path here, and we see that this thing just kind of keeps on going up, and you notice that it does the same thing as we approach it on the right side. Okay, so this is the limit of 1 over x minus 2 squared as x approaches 2 from the positive side. Okay, so this graph, if actually we zoom out, and zoom out, and zoom out, keep on zooming out, you see that it goes to positive infinity. It just keeps on going, it just keeps on going. Okay? So this one, we say that the limit as x approaches 2 from the negative side goes to positive infinity. I'm sorry, from the negative side. And the same thing, the limit as x approaches 2 from the positive side, it goes to positive infinity. So, therefore, we say that this, let's see, as x approaches 2, f of x goes to infinity, or approaches positive infinity. Okay? So in other words, f of x increases without bounds. Okay? So for this one, we're going to say, when this happens, we say that the limit of 1 over x minus 2 squared as x approaches 2 does not exist. That would be your answer. So what would happen if we look at this function, f of x? Let's call this one g of x now. It's a different function. G of x. G of x equals negative 1 over x minus 2 squared. It's kind of like a mirror image. Okay, now it's going down. Okay, so for this one, so as we approach 2, the limit as x approaches 2 of this function, now we have negative 1 over x minus 2 squared. What does that equal? Well, now this graph, g of x, is decreasing without bound. And it's from both directions, from the negative and the positive side. So, just like the last one, very similar. As x approaches 2, g of x approaches negative infinity. Okay? So g of x decreases without bound. And once again, we say that the limit does not exist. Okay? So now what I want you guys to do is add some properties to your notes. So let's see, worked ahead, so they're already done. I already have them copied here. So copy these down. Remember, you guys can pause this, copy this, then keep on playing. And we go all the way to 4 of them, 4 properties. Okay, pause it, copy these down, and press play again. Okay, I know there's a lot of students in the past, I've noticed a lot of students kind of tend to forget this one. It's a very useful one. Okay, but these are pretty much they're self-explanatory. Pretty much, you apply them just as you see them. They're very, very, very easy to apply. We'll do some examples. So, to get an example. The limit as x approaches 3 of x squared times 2 minus x equals what? Okay. Well, it's just like the property tells us. Okay. Now, a good idea for you guys, little side note. A good idea for you guys is as I work out these examples, you might want to pause them, try them on your own, see if you can figure it out. It's always a lot better if you can figure it out on your own instead of seeing my guidance and then you apply what you learn by watching me. It's a lot better if you can challenge yourself and try to figure it out on your own and see if you understand the concept. Then press play, then see if you got the correct answer. But pretty much we are going to do direct substitution. Okay? Okay, and that's pretty much what you should take from the properties that you just copied down. All it's telling you to do is directly substitute the x value that's being approached. So in this case, we're approaching 3. So we are going to substitute 3 okay? So you should get 9 times negative 1, so your answer is negative 9. Okay. Another example. The limit of x squared plus 2x plus 4 over x plus 2 as x approaches 2. Again, try it on your own. But, ooh, that looks like a P. Direct substitution is what we should be applying here. Okay, this time we're going to directly substitute a 2 for every x value. Okay, so we should get 12 over 4, which is 3. Okay, so what we're doing here is now I'm not going to take up the time to graph this and then see what try to see what the limit is by looking at the graph. I'm just directly substituting using the properties. We're moving on from, we don't always have to graph it. If we're not given the graph, we can find the limit another way. We don't want to spend time graphing, especially on the AP test. You don't want to kill time by graphing when you can do this method. Okay. Let's see, another example. Well, this starts getting into your homework. So I'm just going to stop it here. We'll talk more tomorrow. Here's something that you guys should think about. Will the direct substitution work? This direct substitution method, will it work on these previous problems that we already solved by looking at the graph? Okay. See if we can apply the direct substitution method. Okay, so that's something to think about. We'll discuss that tomorrow. I'll see you guys tomorrow.